This problem is related to the concept of geometrical optics, and in this problem you have been given a sphere. Refractive index of this sphere is n. A light ray is incident on this sphere at this point. This is the normal on this surface, that is, this line passes through the center. Angle of incidence is given, that is, this angle is theta naught. Now at this point, or you can say at this surface, this light ray undergoes refraction, and the angle of refraction is given, this angle is phi naught. Now on this surface, that is on the back surface, this light ray undergoes reflection. This is the normal to this surface, that is, this is the center. So this line is passing through the center, so this is normal on this surface. And finally, once this ray reaches here, it undergoes refraction again. And this is the normal at this point, or you can say normal to this surface. So we have been given, that is, this ray undergoes total angle of deviation of alpha. Then we have to find relationship between n, phi naught, theta naught and alpha. Basically two lists has been given. In one list the value of n alpha has been given, and in the another list the possible value of theta naught has been given, and then you have to match the entry. So if you get a relationship between n alpha and theta naught, you can basically check all these entries. We will check 1 and 2, that is P and Q, and R and S you can check yourself. So this is the situation. We have this sphere and this light ray incident at angle of theta naught, and we have been given total angle of deviation, that is alpha. So let us try to figure out. Now this light ray can undergo like this if there is no sphere, there is no refraction, but it has undergone like this. So this is basically deviation. So how much is this angle? This angle is theta naught, so this angle will be theta naught, because these two angles are opposite angles, and this angle is phi naught. So this means this angle is theta naught minus phi naught, and this angle will be phi naught. Why? Because now this is the radius and this is the radius. So this means this is an isosceles triangle. So in case of isosceles triangle, the angle on base are equal. So this angle is phi naught and this angle is also phi naught. And at this point, this light ray undergo reflection. This means angle of incidence is equals to angle of reflection. So that is, this angle is phi naught, then this angle is also phi naught. Now this is radius, this is radius. So in this triangle, base angle this and this has to be equal. Now this angle is phi naught, then this angle has to be phi naught. Now due to the symmetry of the problem, this angle has to be theta naught, because this angle is theta naught, then this angle has to be theta naught. And this can also be stated based upon the reversibility of light ray. So basically if you pass a light ray in this direction, that is, if it goes like this, then like this, and then this, and finally refract on this surface, it will come like this at angle of theta naught. This means this has to be theta naught. So either you can use the concept of symmetry, or you can use the idea of reversibility of light ray. In both cases you can say this angle and this angle is equal and both are equal to theta naught. Now in the problem, total angle of deviation is given, that is alpha. So let us try to figure out the total angle of deviation. First deviation occurs on this surface, second deviation occurs on this surface, and finally the third deviation occurs on this surface. So what I will do is, I will find angle of deviation on this surface and this surface, and I will add. So let us first find on this surface. This is the light ray, the original path, and this is the refracted path. So this is the angle of deviation. And as I said earlier also, this angle of deviation is theta naught minus phi naught, because this total is theta naught and this is phi naught. So this is theta naught minus phi naught. Now on this surface, this is the initial path, but this is the refracted path, or you can say reflected path. This means this is the angle of deviation. How much this angle will be? This total angle is pi, because angle on a line. This angle is phi naught, this angle is phi naught. So this means this angle is pi minus 2 phi naught. So this angle of deviation on this surface is pi minus 2 phi naught. Now what will be the angle of deviation on this surface? This is the original path of light, but this is the refracted path. This means this is the angle of deviation. Now this is phi naught, then this angle will be phi naught, because opposite angles are equal. And this total is theta naught, so this means this is theta naught minus phi naught. And this is same as this deviation. So now what is the total deviation? I can say total deviation is this plus this plus this. So if you simplify, the total deviation alpha will be, this is pi and this is theta naught plus theta naught, that is 2 theta naught, minus phi naught minus 2 phi naught, that is minus 4 phi naught. Let us call this as equation 1. Now I will use a Snell's law on this surface and this surface and this surface, and finally I will get the corresponding relation. So let us apply a Snell's law on this surface, that is first refraction. So on this surface I can say n1 times sin theta equals to n2 times sin theta, or you can say angle of refraction. In this case n1, that is refractive index, is 1 and angle of incidence is theta naught, that is n1 times sin theta naught, that is 1 times sin theta naught. And here the angle of refraction is phi naught and refractive index is n, so n times sin phi naught. Now the part P of the question, this says what happens if n equals to 2 and alpha equals to 180 degree, that is pi. So let us use this fact in equation 1, alpha equals to pi. Let us plug this value. So alpha equals to pi, and this side I have this value, so pi cancels, so I will have 2 theta naught minus 4 phi naught equals to 0, or I can say theta naught is equals to 2 phi naught. Basically here one term is missing, that is this is equals to 0. So from here I am getting, that is theta naught equals to 2 phi naught. So this is the relation. Now let us use this as Snell's law, that is sin theta naught equals to n times sin phi naught. Now you can plug the value of phi naught. The phi naught is nothing but theta naught by 2 from this equation. So phi naught equals to theta naught by 2. So I will have 1 times sin theta naught, and this is equals to n times sin theta naught by 2. And I can use the formula of sin 2 theta, that is sin 2 theta is equals to 2 sin theta into cos theta. And I can also plug the value of n equals to 2, that is given in this part. So sin theta by 2 and sin theta by 2 will get cancelled out, or you can take common, and in that case sin theta by 2 equals to 0, in that case theta naught will be 0. You can get the same answer from other part also. So we will have Here the term left is 2 cos theta by 2, and this side you will have n, that is 2, because sin theta naught by 2 and sin theta naught by 2 from this side got cancelled. So cos theta naught by 2 equals to 1. This means this is equals to 1, that is, this means theta naught equals to 0 degree. So for this part I got the value of theta naught, that is equals to 0 degree. Now let us consider Q part. In this part the n value is given, that is root 3, that is refractive index, and alpha is given, this is equals to pi. So we have already derived that this expression 1 times sin theta naught is equals to n times sin theta naught by 2, and I can use sin theta equals to 2 sin theta by 2 into cos theta by 2, and I can plug n equals to root 3, and I can take sin theta by 2 common, then I will have this. So either this term is 0 or this term is 0. If this is 0, then theta naught equals to 0. Because this is equals to 0, this means this is equals to 0, this means theta naught equals to 0 degree. And if this is 0, then this means cos theta naught by 2 equals to root 3 by 2, and if this means theta naught by 2 equals to pi by 6, and that means theta naught equals to pi by 3, that is 60 degree. So for this part, that is part Q, theta naught equals to pi by 3 or theta naught equals to 0 degree. Similarly, you can check the other two parts R and S. We will not need to write a Snell's law on this surface, because on this surface we have reflection. So we have used this fact that this angle is equals to this angle. And on this surface also you will not need to write a Snell's law, because this point and this point is symmetrical. So even if you write a Snell's law on this surface, you are not going to get additional equation. The same equation you have already written. So I hope you enjoyed this problem, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.